Greetings, math friends. A long time ago, I had attempted to factor this quartic polynomial into 4 binomials. And apparently I had made a mistake and didn't realize it. I had a couple of viewers that kindly suggested factorizations for this. I'm going to attempt to redo this, and hopefully without mistakes. The way that I'm going to approach this is to recognize the quadratic pattern in this. If we rewrite this slightly, we can see that it has the quadratic pattern. I'm going to do a u substitution and let u equal x squared, and then substitute that in here. Now that we have substituted, taken an x square out here, x square out here, we see that this definitely is a quadratic. With that being identified, we can use Sridharacharya's formula to find the roots of this polynomial, so the places where it's going to cross the x-axis. Now, just because we know where it crosses the x-axis does not specifically tell us the factors, but we can work from those roots to find the factors that we need. Just noting Sridharacharya's formula here, I need to identify the A, the B, and the C here to substitute into the formula. The coefficients are the values that we're looking for, not the variables themselves. 16 will be the A value, negative 33 will be the B value, and 2 will be the C value, and I plug that into this formula. Here's the first round of substitutions. Since there's a negative in the formula and this value is negative, this becomes a positive. Because we're squaring here, it doesn't matter if it's negative or positive. We're going to multiply these 3 values here, and then we're going to divide by 2 times 16, which is 32. As we work through the simplification of this, we end up with 33 plus or minus 31 divided by 32. That gives, for case 1, u is going to be equal to 2, and for case 2, u is equal to 1/16. Now, we haven't actually found the roots yet of the original problem, which was a quartic. We need 4 of those. We only found 2 values. The reason is because we made the substitution previously that u is equal to x squared. So to actually solve for x, we're going to need to take the square root of each of these values. Since we substitute u is equal to x squared is equal to u, which is equal to 2. To solve for x here, I am going to take this to the 1/2 power. So I'm going to get that x is equal to either the positive or the negative of square root of 2. If I want to make this into a binomial, looking at just the positive version, I'm going to move the square root to the other side by subtracting this to the other side. So here's my binomial, and it's equal to 0. I'm going to do the same thing with the negative version of this. Add it to both sides, and I'll get x plus the square root of 2 equals 0. Due to the zero product property, I can multiply these two values together, and it's still equal to 0, but I will have a product that will be a partial product of my original. Over here, I'm going to do something similar. I, again, want to solve this for x. Bringing this down to equation, I can take the square root or take it to the 1/2 power. If we're taking the square root, we need to make sure that we pick up the negative version of this as well. Looking at just the positive version here, I'm going to bring this 4 to the other side. And then I'm going to subtract 1. And this is equal to 0. I'm going to do the same thing with the negative version of the quarter here. And that will give me 2 factors from case 2 and 2 factors from case 1. So that is a total of 4 binomials that, when I multiply together, will give me the original quartic. All right, I have these 4 factors that I've derived, and now for writing the solution. When I had made this video originally, my intent was to have 4 binomial factors, which is what I have here. But many people will be instructed that if you have a factor which is considered prime, something that would generate the irrational numbers or some kind of a non-integer factorization, then you would leave it in this form rather than this form, breaking it into the irrational factors. So to go with my original intent to find 4 binomials, I found those 4 binomials here. And then if you do not want to see the irrational values here, then you can multiply these 2 binomials together to get this single binomial, which does not have the irrational values present. And these 3 factors, again, will multiply to give you the original quartic equation. So for probably a lot of textbooks, this would be the factorization that was expected. Hopefully this has been a better presentation than my previous one, and then my commenters can let me know what they think about this version. Hopefully you find some mathematics in your part of the world to enjoy. Cheerful calculations.